Well, let's talk about variance and inferential statistics. Imagine two experiments in which we had treatments 1 and 2. You see in the left-hand box there in experiment A, treatment 1. And maybe this was some average test score, who knows. But it looks like an average of 35. And over in treatment 2, you have an average of 40. One thing I'll have you notice is how compactly distributed the numbers are. The standard deviation must be very, very, very small in experiment A in both conditions. Now, having said that, would you prefer to present that data or the data in experiment B? Look how spread out the numbers are in treatment 1 and treatment 2. But I'll tell you something kind of interesting. The means are the same. The treatment 1 mean is 35. The treatment 2 mean is 40. Doesn't it sort of lend itself to chance in experiment B? Doesn't it seem to be the case that the outcome of those two treatments, whatever it might have been, may more likely have been chance than up in treatment 1 and 2 in experiment A? And that's one of the things that we'll talk about when we get to inferential statistics. When we're talking about statistical significance, lower variance actually helps the outcome. It really does. It's one of those things that benefits the researcher. And I'd rather have the data from experiment A than experiment B. Now, it's never as perfect as experiment A represents. That's just a dream situation. But nonetheless, that's something I strongly prefer if I could possibly have it. So that's sort of a take-home message here as a preview for future times, is that we'll have inference tests that rely on variability to some degree. It'll be a difference between the sample mean and the population mean divided by how variable it is. And if there's too much variability, it tends to undercut that inference and may not yield statistical significance. And down in experiment B, of course, you can tell by looking, a gigantic amount of variability. Over in treatment 1, the scores range from 57 to 15. I mean, that's crazy. But up in treatment 1 in experiment A, it only ranges from 34 to 36, which again is unrealistic, but intended to illustrate a point.